If I asked you to imagine a scientist at work, chances are you're seeing them in a lab, wearing a lab coat, mixing test tubes and beakers, measuring or collecting data by doing lab work. And you're not wrong for that. Lab work is pretty much a fundamental of science. But lab work has some drawbacks. It can cost a lot of money and take a lot of time. Lab work creates waste, both like plastic disposables, but also hazardous waste. That stuff can't be easily disposed of. I'm going to be talking about soil science, and if you're farming 40 acres and want to test your soil, how many lab samples will you need for that? What if it's 400 acres? This is where my research comes in. I'm posing the question, what if you could obtain the same quantitative data, numbers from soil samples, not by doing lab work, but by doing something simple as taking a picture? My project is attempting to predict known lab data for soil samples, specifically their phosphorus content, based solely on the wavelengths of light that the soil reflects. Now, wavelengths of light and reflectance are really just a fancy way of saying color. So can the soil color tell us how much phosphorus is in it? Well, for one, soil is not all brown, I'll have you know. And second, humans can only perceive a tiny portion of the entire wavelength spectrum. I'm using a device called a hyperspectrometer, which does not have that same limitation. This device can measure the amount of light reflected at every wavelength from 350 to 2500 nanometers, and then show that data on a graph like this. This rainbow section is the only part that's actually visible to humans. You can tell in the image that the soil looks like it's different colors, but in this rainbow visible range, these lines on the graph, or reflectance curves, if you will, are grouped very close together. They really only separate farther into the infrared regions where most of the data is anyway. So what color is phosphorus? Well, I can't really tell, but my statistical models could. I built one with machine learning and another with a type of regression to take in this reflectance data along with the old-fashioned traditional lab data values to put out a predicted value for each sample's soil phosphorus. The real test comes when I put in a sample's reflectance data, but not its lab data, and then I can compare how accurate that prediction is. And these models did a generally good job predicting soil phosphorus, specifically to an R-squared value of 0.8, and the closer to that number is to 1, the better. I also tried this experiment with heavy metals in wildfire ash, which is a question that has never been attempted before with this hyperspectral sensing. Those models didn't do quite as good a job as the soil ones did, but it was still an important first step. I believe that my results should be explored more in the future because these models could make it very, very easy to assess environmental data over huge areas as they could be observed by drones, planes, or satellites instead of your imaginary scientist working in the lab. Thank you.
Thank you, Paul. I think the two of you need to talk, right?
I think so.
I got a book for Christmas from my father called What Your Food Ate, which is all about what's in the soil and how it affects the rest of us when what we eat. And so I'm starting to learn a little bit more about what soil, the impacts that it has on our environment and our nutrition system. But what got you interested in studying soil?
I can attribute my passion for soil to the people that I've met along the way. I had really inspirational instructors just in the entire field of earth science, starting in high school and then progressing through my undergrad. It's really because of the professors I've had and the experiences, like the research and just the camaraderie that is experienced in the whole field of soil science that makes it really special to me, but is also motivating me to continue on and stay so interested.
So you were working on your master's or your PhD?
This is from my master's research. I just finished it up last semester, but I'm continuing into a PhD now.
Okay, great. Well, thank you so much.
Thank you.
Good job.